Hello. That's very weird to do a presentation on live without seeing people's faces or anything, so bear with me. Thank you very much for joining my talk. I think we've all kind of been in this situation of building software and failing and trying to make it better. So this talk is going to basically try and suggest or propose a new way of looking at design, and I'm going to go through my experience, and hopefully it will resonate with you with how we go about designing monoliths, and then talk a little bit about DDD and some principles of DDD that I'm going to use or borrow for the proposed way of looking at how to design a system. Then I'm going to go through some bits, how would that look in practice when we take a very simple sample or use case. And then we're going to have a quick Q&A. And after the Q&A, I'm going to do a short summary. So, yeah, so I've been doing software for a couple of decades now. It's my third decade doing software. And I've seen this pattern coming again and again when we build software. So we start off with analyzing the domain. We're looking at talking to the business and understanding what we're trying to build. And we might be looking at the different actors and entities in the system. We model them in a big database diagram. That's very exciting. We put all these tables together, and we analyze what interacts with what and what depends on what, and we kind of come up with this. This is, of course, like a tiny segment of a big, probably much bigger diagram, but kind of to illustrate the idea, it's like, entities that are that each entity is its whole, has all its properties, and we have referential integrity between the different entities, the different fields in the entities, usually primary keys, and those describe the interaction between the different entities. So we say that, in order to, when we create a user, we need an address table for that user. And then if we create a product, then the product has some items or colors or prices and so on and so forth. And those are usually kind of interlinked using referential integrity. And we're happy with our model. We looked at it and we built this data model. And now we start looking, adding the kind of the data layer, code, and some business logic. So data layer is usually just some form of idea of an ORM mapper with some abstraction that hides the database away from us and allows us to do things against well-defined entities. Then we add some business logic layer on top of it that might have usually the process segmenting the logic that happens every time we do some action against this entity. We add some other layers, excuse me. And then like security and maybe APIs and all kinds of things like that. And then we start building the UI. And when we start building the UI, usually things start to feel a bit awkward because the very great design on the back end now is trying to kind of mesh into a view that we're showing our users, and we're we soldier along. We have a good design. We build the UI on top of our backend system, and then we put it into production, and we do some customer acceptance tests and some stages, and going through staging, and we go to production, and everything's dandy, right? We have our system out live, and hopefully we built more or less what the business wanted. And then we start with trickling of change requests. Yeah, we say, oh, this is not exactly what we wanted. Can we do this looking a little different? Can we validate some information when we do some actions on the screen? Can we show the catalog differently? Can we have some reporting? The system evolves, and we kind of slowly our code base evolves. Yeah, and that's all well and good, and we get like a year later, we are now in a, you can say that the system is like hardened, and there's a lot of users using the system, and change requests are trickling in, and the team changes, all kind of things like that happen as we go along, and things start getting a little slower and a little slower and a little slower again and again, and it is kind of a real symptom. In the beginning, when we had the change request, it was no problem. We put it into production, maybe a week after we did the change, everything was fine. Yeah. Then the second year, it takes about a month. Yeah, because every time we make a change, there's a lot of of course the code base has grown. There were a lot of hacks going around. Now it's like every change you make has a lot of side effects, and there's a lot of generic code that does all kind of things that you're not sure what exactly is there. Then you have like all these, pages, those classes that have like 1,000 lines of code that if you're trying to figure out what's happening there, that's a real nightmare. So, and then, the business comes along and says, oh, just a couple of more things that we didn't think about. Can we do some integration with the CRM and our stock management and logistics? Can we also kind of incorporate logistics in the system? And at this point, you're like, you're going like, can I find another project in the company, or maybe find a new job altogether? But you know what? We just soldier on, and we go, yeah, we'll hack, and we'll get it sorted, and we deliver those those requests that really kind of cause the beautiful design that we had in the beginning to become really tangled and very just something like this, a big ball of mud. Everything talks to everything. There is no cohesion. There's coupling everywhere, and every change you make to the system, somebody came in, a new developer came in, and he wanted to just show some data on the UI, so he was afraid to touch the business layer and all the underlying layers, so he just went directly to the database. Yeah, just no problem. This is he got his issue sorted, and then there's all kind of shortcuts. Again, the design that was in the beginning was great, but now things have changed, and this is there are like 5 different places or 10 different places or 100 different places in the code in different layers that change that one entity or a collection of entities. So we get to a point where it's like, you know, we can't do anything anymore. It's like every change that you need to make is huge risk. Every deployment, every attempt to deploy it to production introduces new bugs. You fix the new bugs, you stabilize it. You know, then there's a performance issue. You fix the performance issues, and you stabilize it. So the whole, you know, from end to end, every release is like 3 months long or maybe more. Yeah, and every time somebody comes to you with a change request, you go, you know, if it's not really valuable to the business, we better not do it. So what do we do now? You know, where do we go now? What's the usual kind of path? Yeah, and in my roles, it was usually like, yeah, let's go to the management, to whether it's the architects or the CTO or CEO, and say, listen, this is not going to work anymore. You know, we got to the end of life of this system because every change is super expensive, super risky, and it doesn't scale, and it doesn't, you know, it won't live for a lot longer. So what do we say? Oh yeah, let's do a rewrite, right? And of course, rewrite is a great fantasy, but the reality is that you don't really have an option there. Yeah, like rewriting is usually if the system is in production and you have a lot of users and you have a lot of data, that's going to take, you know, 18 months to build, while trying to, in parallel, maintaining your existing system. That usually, like the 2 rewrites that I did in my life, one was like a huge risk and took, instead of, it took, you know, the best part of 2 years, and we really ended up with the same problem after 2 years later. Yeah, and the other one, we never went to production because after we had the 2 versions running side by side, we were looking to migrate the data, and we had like many terabytes of data, and the migration plan that was supposed to migrate from V1 to V2 would have taken 3 months to run. Yeah, to be actually physically run the procedures to do, you know. So that never happened. That never got to V2. And of course, there was a big consequence to that, and we ended up just running V1 on V2 and V2 in parallel, and then it took another 2 years to just kind of, I don't know, sunset V1. But we never got all the data from the old system to the new one. So what we really want to do is to basically take small chunks and move it, you know, refactor if you wish, and slowly move stuff from the old system to the new system, effectively from one design to another, effectively doing it on the same code base. And there are many patterns to doing that. The strangler patterns, there are patterns where you slowly, you know, you build API across your backend, and slowly kind of move stuff from one boundary to another without changing the APIs, and eventually you will get to your newish design. Yeah, but So the source of this problem is the way we designed the system in the first place, right? And we find ourselves in the same place again using this database domain model monolith style, yeah. And I think the definition of insanity is doing the same thing and over and over again, expecting different results. I think it's not Einstein who actually said that, but he was giving credit for it. But this is exactly what we're doing, right? We're saying, oh yeah, we'll just rewrite. Now we know that, and we have all these new frameworks and this new technology, and we'll do it on the cloud, and we do it like that, and whatever, and we'll do it better this time, right? And we repeat the same thing, and we end up with the same problem a couple of years later. So is there a better way for us as developers to design our systems and make our users happy and a business successful? Yeah, is there a way to do that, to hit nirvana? And I'd argue that yes. So let's look at a different way. So I read this book 12 years ago. I think the book was published in 2003 or something like that. Eric Evans wrote the DDD book, the Blue Book, as it's called, in 2003. And he talks a lot about how to look at your domain, how to make the domain a lot more meaningful in your design and how to make it more successful. And he introduces a lot of interesting things there. But what I took away from this book is the concepts of bounded context and strategic design, which are a lot more aligned with, like, if you wish, service-oriented architecture or microservices today. Yeah. So the I don't know, a good description of the book is by Martin Fowler, is that DDD deals with large models by dividing them into different bounded contexts and being explicit about their interrelationships. So what I really what really resonated with me and changed the way I looked at software, and with of course other influences from Woody Dahan and others, is that at the end of the day, what determines what the software is doing is the user's activity. What is the user doing against against the system, or what is it trying to do, and trying to what is the success? You know, you probably know from unit testing this idea of having a story, and the story says, oh, as a user, I want to do this thing, and I put a success criteria in this statement saying, you know, when I add €1 to my bank account, I have €1 more in my bank account, or if I withdraw €100, there's €100 less, right? But this is what we do, right? We are interacting with the system. A user is interacting with the system, and he's trying to make a successful interaction with the system. And if we focus on those user activities, all of a sudden things look very different. They make a lot more sense. It's easier to change them because we deliberately say this is what this user is doing against this data or this set of business rules, and it makes things opens your mind to how you look at things. So let's say if we talk about bounded context, let's talk about the words. Yeah. So context, I think most of us from being developers deal with context every day. So context is the information surrounding an idea, and it clarifies the meaning of what are we doing. So it's the settings, it's like the scenario of which a work or a statement appears that determines its meaning. Yeah. So it's like if in one context, when you set the stage to do something, then it's very clear that everything that we do in this context is what we're intending to do within those boundaries, yeah, within those what we said in the context, yeah. So here we go to the other word, which is boundary, and boundaries is exactly kind of with context kind of gives us the meaning to say, listen, we are not dealing, all these other things are out of scope, yeah. Inside the boundaries is what we are dealing with. It's like it gives us the definition of it could be an autonomy and coupling and what we own. So inside the boundary, we have autonomy because we act in a certain context. We have ownership of what we're doing, and we declare it clearly. We are inside the context of something that we're trying to do. Yeah, and it also kind of implies coupling. Yeah, so inside the boundary, it's like things that we are responsible for and things that we can affect, we can do stuff about, we have authority and ability to act on. Yeah. And outside it's all the things that we have we can't make changes to, we can't really we can command inside a boundary. Outside the boundary, we can only say, hey, listen, I just done this thing. If you want to know about it, here you go, right? But I can't tell somebody else to do something because I'm out, this is outside my boundary, yeah? This is outside there, I'm outside the other thing's boundary, yeah? So I'm trying to, by defining those boundaries, I have autonomy and I have and I also have relatively loose coupling from two other bounded contexts or boundaries around me. And putting those two concepts together is the bounded context. So a bounded context, by Evans' definition, is the condition under which particular model is defined and applicable. So a thing or a component or a piece of component that does a certain action is a bounded context, and it's this kind of definition or the cohesive component that does what it says on the tin, basically. So if I say that I'm the component that does the user registration, for example, then in my bounded context, there is everything to do with user registration and nothing more, nothing less. Yeah, and nobody else in the system is responsible like I am to act, to change, to make changes, to make state changes, and to be responsible for those changes. So obviously all the business logic that has to go with, this kind of bounded context of my favorite example of user that you'll hear throughout the presentation, the user registration is a bounded context that is very specific to registering the user. That means that I own certain aspects of the user entity. And here it's interesting to look at it because that doesn't map very well to entities anymore. Because if I want to act on the user, I don't need the user's address. I don't need the user's, other things, all kind of reference stuff, his bank account, his payment methods, his payment cards, his communication preferences. They're not related to my component that does the user registration. It is only the fields from the user entity, the classic user entity that I'm going to use. So we're going to look at this in the more practical side of the talk. So the point is that the bounded context is is dictated by as small as possible collection of things that happen together to complete or to make a business function or a business requirement a reality. Yeah. So if I want to add a user to the system, I will need to authenticate him or to create an authentication context. And then I'll have another, maybe another component that does the collection of the verification of the user. And then there's another, maybe another component that inside the, this larger context, but another bounded context that will take care of creating an account for the user, or maybe maybe this is another component altogether. It's important to kind of find those bounded contexts early on and identify, even at the design phase, of what is the user or the actor, whatever it is, trying to do in our system, and why is there business meaning to what's happening here? Yeah. Hope that makes sense. So I don't know who of you, I might show my age, but Dune is, I can't remember if it was in the late 70s, early 80s. The book, I think, is much older, but I've always loved Dune, and this is the scene where he's fighting the robot that's trying to kill him, and he's using the voice to attack the robot, and really cool stuff. Anyway, and let's get to our thing. So here is a regular starting point. Yeah, this is our what you usually, that's how we'd usually be building databases, right? And I'm going to focus in on the user entity here. Okay, so that's the traditional user entity. It has an email, first name, last name, password, contact, birth date, and payment options, and addresses, and made easy the preferred customer, and so on and so forth. And in a traditional system, that's what you usually see. Of course, I know you're all going to jump and say, oh no, but we don't do this anymore. We do like a user with a small table, and then we do another small table for contact details, another table for payment options, another table for address. Yeah, I know all that, but logically that user starts off at this kind of identification that this is all a user, and those other tables that I just called out, they are usually they would be linked to the root user entity with referential integrity, which means that every time you do some changes to a user, you'll have to have all the other things if you want to create it, yeah, or you create null objects or whatever, but you have to do it in one transaction, yeah. And that immediately means that the user object has something like update user. I don't know, you probably saw this in your code. I wrote it myself many times and thought I was brilliant at having this generic, beautiful generic interface that I could throw anything at it and it will do all the magic, right? But of course, inside this method that was update user with some data as an argument, and maybe some Boolean fields in addition, that inside that method, I really went and did, if this, then that, if this, then that. So we had like hundreds of code paths, yeah, of permutations of what could happen if this is null and this is empty and this is missing and this is after we validate that, then we want to, I don't know, maybe send him an email and maybe send him a text and maybe reject him or maybe throw an exception or whatever it is. It was a really, you probably saw those class, mostly in MVC, a huge single class that has this method on top of it and as a signature, and it does just, as you read through the code, you go, this could happen now, this could happen now, this could happen. If you want to change something in the behavior, it's almost impossible. And to predict what's going to happen, and no unit tests and nothing like that could help you with that, because it's just incredible. It would be extremely hard to compensate for all the different permutations that could happen. The more data we have, the more variables we have, the we need to compensate for that. Yeah. So let's take a different approach and look at what we said, like what we could assume. Now again, this is like a very lightweight and simple scenario. But let's say that we have one bounded context that is user authentication. Yeah, this is a very basic thing. Yeah, we need to authenticate a user, and we'll say that we have a component, we have a bounded context where user authenticates. Yeah, and that assumes, of course, that the user is registered already, or we added him to our. Of course, we can say that the user authentication bounded context includes the user registration or the user sign-in, sign up. So in this, for the user authentication bounded context, we need the email, we probably need the password, and we might or might not need something like email verified. So for example, in order to say that we actually we signed up a user, we have to verify his email, otherwise he's not a real user. Yeah, so we can't add him, we can't let him log on or do act on anything in the system until he is verified. Yeah, so in this scenario, that's one bounded context. When we need email password, we need the email verified. We probably would have one screen to enter your username, enter your password, or email and password. It might be a username in addition to that, I don't know. And then we send him an email and he clicks on the email and it comes back to another component inside this, another bounded context in the user authentication or another method, sorry, in the bounded context that verifies the email. Once the email is verified, we then let the system know that this user was created and his user ID is so and so, okay? Last login date, for example, would be, again, in user authentication, every time a user would log in, we'll add a login date. And if we decided to block the user, then we have a block date. And of course, once that date is not null or is set, then the user cannot log in. Another one would be the customer contact. And again, customer contact means the bounded context of modifying the customer's contact details. Yeah, so we need the last name, first name and last name. We need the contact email, which could be very different to the login email. Yeah, so we don't want to tie them together, right? And again, that's like a great example of context. We have two fields here that mean the same thing, but we have two versions of them, if you wish, that are in two different contexts, one in the context of authentication and one in the context of contact. Yeah, we'll have a phone number, we'll have a home address maybe because we need to post them stuff, and then we go on, doing the same thing. Look at billing. What's billing related stuff? So we have the payment option and the payment card maybe, and we have a customer account, which might be, which is more meaningful than the authenticated user. So we have authentication and we have authorization. and roles and all that, and that's more kind of customer account land than authentication. So we have the customer account. Maybe it means that he's in a company. You know, maybe there's another entity here or another concept of a company, and he might be a account. You know, his account is a sub account of a company account or something like that. Yeah. So we have account active, for example. So that also implies that, you know, we can have a user authenticate and log into the system, but he's not active. So he won't be able to do anything because we're waiting for some other verification or somebody to admit him to our system. We have, is that, what was that? Date of birth. We have the whether the verified mobile is verified or not. Again, that could be in customer account, that could be in authentication. I don't know. It depends on, again, the user, what you defined as your bounded context. And for example, this is here we have is preferred. So is this a preferred customer, right? And it could be in the customer account, it could be in the sales account, I don't know, in the sales bounded context, sorry, not account. So, but again, these are things that we know based on how we look at the domain and how we design the domain, yeah? And then we have just a quick example of shipping, and shipping will take that field of the shipping address. And now what we end up is we don't have an entity anymore. Yeah, the user is basically distributed across those different bounded context. And probably in real life, when we build this from a technical perspective, every bounded context will have its own table, yeah, at least its own logical table or its own fields that it's responsible for writing and making changes to. And just let's be clear about it. User authentication is for example, is the only one that's responsible for username, password, and last login date and all that. Nobody else can change those fields but user authentication, yeah? So you could say that some other, let's say a fraud, you know, let's say we have a fraud component or whatever, a fraud service, and the fraud service says, finds that this user is appearing on some database, and he'll publish an event saying, hey, this user is fraudulent, right? Please block him, right? So the consequence of that would be that the user authentication component will get an event that says that this user, and all it is a user ID, yeah, in this event is fraudulent, right? And then it will trigger its own business logic, its own understanding of how to implement a fraudulent user lockdown, yeah? So maybe he will not lock him down. Maybe he wants him to log in, but he'll flag him. Maybe he's going to send him an email to clarify this going into some questionnaire. I don't know what, or he just blocks him from that date, and then the user can't log into the system anymore. So those kind of what we end up is basically a distributed entity, yeah, where we're taking all the fields that are relevant to each bounded context, and they belong to each of those different bounded contexts. I usually use the term component, and a component would be, you know, a collection of components can be like a service or microservice or whatever you want to call this, but this is like, you know, all the things that have to do with you know, the financial stuff is going to be with the customer billing and other customer and product related stuff that has to do with money. They will all sit in this logical boundary of the finance the finance microservice or finance service or whatever you want to call it. You know, however you. I don't want to get into discussion how you define your microservices, but the important thing here is that you can build this very, very quickly and very simply, and it doesn't matter if it's distributed or not distributed, if you're using microservices or not, that doesn't matter. But this kind of design allows you to basically put all that belongs together. So they're very tightly coupled and they're very well defined, and you know what to expect, and you know that all the changes that you make will affect that component and nothing else in the system. Yeah. So whatever you're expecting authentication to do will always happen in the authentication component. It's not going to be anywhere else in the system, not in the UI, not in anything else. Yeah. It's always going to be, you know, this one component that's responsible for that slice of the system. That, of course, implies a couple of things. One is that there's no referential integrity in the database. And I know some of you are DBAs are going to want to virtually strangle me, but that is a no-no, and there's no halfway about it. From my experience, once you start introducing referential integrity, things go wrong because you can't. It basically means that you can't decouple this anymore. You can't break it down to smaller units, because if you say you found that, you know, email doesn't belong here, it needs to be over there, and you need to move it away, you are going to go into a world of pain, right? When you don't have the referential integrity, it's relatively easy. It's still a job, but it's relatively easy to move things around or to change things. Yeah. The other important thing, or the other thing that I probably didn't mention here, is that usually in this scenario, the ID would be a GUID, yeah, and would be created by the client or the creator of the interaction. Yeah, it wouldn't be what we're used to from the old world, which is like, you know, create a user and give me back the user ID from the database, and I'm going to use that. Yeah, we're using a GUID, so we can basically put it in a message, put it on a queue, and go on do our things. We know that this user is going to be created. We can use this GUID then to reference in other interactions in the front end. Yeah. So it's all about coupling, yeah. So it's all about uncoupling the coupling, yeah, and decomposing the coupling, yeah. And of course, there is no way to build a system that doesn't have coupling, because that kind of says that would probably mean that there's nothing there, right? There's no, it's non-functional, right? So we have to have coupling. So coupling inside those bounded contexts, inside your components, there's high cohesion and high coupling, and it's fine. That is expected. We are defining that all these things belong together, and therefore they all know about each other's fields and properties, and it's fine. And it's all like they are tightly coupled. But outside the boundary, outside the bounded context, there should be no coupling whatsoever. If you use messaging, the messaging is the contracts, yeah. So if you're doing commands, they're internal. If you're doing events, they're external, and those events are the contracts between the different bounded contexts. And outside of that, again, or just to reiterate here, the other important thing here is to respect the concept of single data ownership. Yeah. So if I own a bit of the system, if I own some functionality, this is my data, and I'm the only one who's allowed to change it. It doesn't mean that others can't use it in their context. You know, they can read it from somewhere and then go use it as to give them guidance or give them reference about something, but they cannot change it. The other components can't make any changes. In order to make changes to this data, it's they have to go into my component. And yeah, so when you go into this kind of challenge, it's the keep calm and keep chipping away, or keep calm, or whatever. And you know, if you're dealing with an existing system, then you know, of course, start at the edges. Try to find how you can kind of carve APIs in the middle to hide the changes that you're making at the back end. You can, you know, I mentioned the strangler pattern before to slowly refactor the code, but it is an iterative process that slowly you can kind of break down the system. But if you have this tool of understanding your bounded context and where you want to get to, it's a lot easier, and it works really well. Of course, for Greenfield, it's relatively simple, and it makes your life so much more interesting. And once you build something in such a modular way, making changes and updates and refactorings and so on makes everything so much simpler. Yeah. Yeah, the main message that I want you to take from this at the end of the day is like this kind of approach of vertical slicing, and think about this thing that, you know, the user doesn't interact with entities. The user interacts with things he wants to do, with things he wants to accomplish, and these are fields of those logical entities. Yeah, and you'll find that when you take this approach, you will end up with a collection of fields that are centralized around business functionality and not entities. Just one point to, you all know this screen, I hope, I think. If you don't know Amazon, you know eBay, or you know someone else, but these are all examples of well-established systems that use those kind of approaches. And what you see what you see here is a great example of what's called UI composition. Yeah, so the UI is the place where all these bounded contexts, yeah, come and seem like they're all together. Yeah, so the book's cover comes from one component, the ordering options and the billing options and the suggestions and all that, they all come from different components, and each and every widget on this screen might lead you to different bounded contexts, and some of them would be a single screen, some of them would be a collection of screens, and some of them compensate by having interactions on the UI itself between the different components by using, I don't know, JavaScripts and events on the UI, or there might be in some kind of a read model that is predefined to help with getting the data from different components. But when you actually interact, when you change state, then it will be a message going directly to this one bounded context. You can have the same kind of UI composition at the API composition, and you have some, of course, what I didn't mention here, or the whole read side of things, which is very complicated, of course. Anyway, it's hard when you're talking about distributed systems, it becomes a lot harder, but there's solutions and ways around everything, of course. And so think about always, another little kind of tip is that this is going back to command query separation, or not the CQRS but CQS, which is an old thing from object orientation, and that is to keep the actions for reading and actions for writing in two separate channels and two separate concepts. Yeah, that will help you then again be able to do data reads a lot easier. I'm not sure about the time, but we're going to go to Q&A now. and I will summarize. I'll have a couple of more slides about after the Q&A, so don't leave. Let's take some Q&A, if that's okay. I have so I have to use my glasses. Okay, so James Stocker, no, he's the moderator. Sorry. JZ says, if you keep multiple copies of the same data, how do you deal with the problem of synchronization, of data synchronization across bounded contexts or boundaries? I.e., if the address changes, doesn't it go from one context to another? So again, there is no data duplication, yeah? So it's really, let's be very clear about it. The bounded contexts are defined by what can be changed, right? And if I'm the bounded, if I hold the boundary of the address with Jay's question, then I own all the data that has to be related to the address. There are other components that might need to read this data, but they can't modify it. So that's not a copy of the data. I don't see it as a copy of the data. It's like they're using it for read-only purposes. But it's really, really important. If you find yourself in a place where you have this, two bounded contexts trying to deal with the same data, you need to look at it and go, okay, maybe it's the same bounded context. Maybe they all these things belongs together, or maybe we have the boundaries wrong. We should separate it into two different components. One aspect is one context and another is a different context. I hope that answers the question. Bindu, I'm sorry, I hope I'm not misspelling your name. It says, without referential integrity will not lead to performance issues in search and lookup, etc. It's a great question, and again, it's like that's why I said, I kind of alluded to this read model, this reporting database, this thing that is not your transactional data. In the old days of we've been using, I think it's still something that's used today, which is separating OLTP and OLAP in two different contexts, two different things, yeah, two different even servers, two different environments. And one is the transactional data that is used for the operations of the system, and it's not, nobody can read for it, nobody runs reports from it, this is just the data that needs to be kept for operational reasons. And then we do like log shipping or ATLs or nightly batches, whatever, to move the data over to a read model or to a cache or whatever it is. And there we model the data according to the read requirements. Yeah, so you might have referential integrity and all kinds of things like that, because you want those benefits for search, for other things. I hope that makes sense, Bindu.
So we've probably only got time for one more question. So
one more question, okay. I'll answer Umit's question. Do we say that bounded context is single microservices? No. So don't think like that. I know that a lot of people in microservices say, oh, this thing is a physical, once we define something as logical, it needs to be a physical running thing. Please don't do this. Please, do your deployment is a different concern than your logical boundaries. Yeah, so it might be that because of performance or team structure or deployment methodology or pipelines or whatever it is that you do, those aspects will relate to how you deploy your components. Okay, so there's no one-to-one one-to-one relationship there. I'll have to cut it short because, but you can please feel free to reach out to me on Twitter if you have any other questions. So if I want, I'd like you to take away this bounded context is all about the user activities. It will help you to keep your boundaries and reduce coupling between different bounded contexts. And if you can, please use asynchronous communication, use messaging and, message brokers and message queues and all that, because that will help you make everything a lot more loosely coupled, a lot more durable, and a lot more scalable. Use publish subscribe between bounded contexts. That is your kind of go-to if you want to communicate between the two, between different loosely coupled components. And it won't be perfect. Don't worry about it. Iterate, but you can improve all the time, and because you find this loosely coupled structure, it'd be easier and better to do that. Yeah, so I hope that makes sense, and just keep on doing good stuff, and thank you for listening, and enjoy your sessions. Cheers.